this week is spend some time answering questions you have on certain topics. Okay, so think about what you have a question for. If you don't know what you want to ask about right now, at the minimum, you should already have loaded the final exam review document. Take a look at that review document. Maybe try to figure out from that document a topic that you struggled with throughout the year that you want to ask a question about. Maybe you have a specific question, maybe a general question I can follow up with. Okay, but I want to make this focused on what you guys want to do, not on just going over every single topic, because we're never going to get through every topic. Okay, there's absolutely no way we're going to get through every topic during a week of review, so I'm not going to sit here and just start at the beginning. I'm going to ask you what you guys want to focus on. I have a textbook in front of me, so if you have a specific topic and you want to go through like an example problem, I can either pull one out of there or I can try and make one up on my own. Depends on the problem itself.
What is it? The final fluid is everything?
It is. It's about 75 second semester, 25% first semester. Okay? If I were to estimate a percentage, that's what I would estimate it to be. Dirks.
Where are we going to have, like, on the lesson, so we had the L values, the C values, you're going to give us that?
You'll be given every value that you've been given all year, so you don't really have to memorize anything that you haven't been told to in the past. Okay?
Just start with what you think would equal those mistakes. Like whatever, like how we like really think
I mean, collectively, I think the topic of projectile motion and forces are two of the harder topics. Which one? What kind of question? Free fall, horizontal, shot at an angle? Like, there's so many topics. At an angle? All right. So let's look at an example to start where an object, let's say an object starts at a certain level and is fired from a cliff, and the object travels a certain distance in the x direction. Let me make this distance exactly where it started. To look at the document? Sure. So the object lands out here. Now, a question like this is a general question. I can obviously become more specific to what I want to ask of you, and I can start filling in locations. So for example, maybe I'll give you the x displacement, and maybe I'll ask you to find the maximum height. Maybe I'll give you the initial velocity and the maximum height, or just the initial velocity, and have you find out the x displacement. There are many variations of these types of questions, so I haven't filled anything in yet. But the concept is the same. What do you always begin these problems with? How do you begin these types of problems? Dirks? Okay, so, but again, I'm saying we don't know any numbers yet. Generally speaking, once I give you numbers and tell you the situation, how do you begin these problems? Before we even go, what is it?
X, Y chart?
Yeah, look at the x and y directions. You always split up your x and y directions, just like we did with forces in the x and y direction as well, in chapter 4. This is chapter 3, in case you're wondering where it is in your book. Okay? So, let's say that I tell you that the distance from the base of the cliff, or from where it was fired rather, because the cliff is a little bit further out than where it's fired. Let's say that distance is 300 meters. And what else could we know? I'm going to have you find the height, though. Actually, I'll give you the height, and we'll find the initial velocity to make it harder. Is that going to work? Yeah, that'll work. All right. Say again?
If we watch every single video you recorded, how long did you guys?
A lot of time. I don't know.
Like you should have started last week.
Like weeks.
It's probably a long amount of time.
What is a long amount of time?
He said, how long would it take to watch every video that I've created on Moodle? I said, probably. Thanks, Jack. Thanks. It's hours at least. We all agree with Jack, right? It's got to be hours, right, Dirks?
Dirks, you did that for the
Dirk
first
says
time.
it's hours. Johnny, Dirk says it's hours.
So we have the x and the y direction. In the x direction, the displacement is 300 meters. In the y direction, guys, relax. In the y direction, what's the displacement?
300.
200.
That was
200.
No, 200.
200.
100.
What's the question?
What's the displacement in the y direction?
0.
100. I don't know.
What is it?
Negative.
There it is. Negative 200. This is where our vectors are important. Okay, remember the object travels down. That's a negative displacement. And let's say in a problem like this, our goal is to figure out the velocity of the object when it's launched. And we don't know the angle either. Actually, we might need one of those pieces of information. Let's see. We're going to need one of those pieces of info. So let's say we know the angle. We know the angle is, let's say, 30 degrees. Okay? Our goal is to figure out what is the initial velocity of this object. What is the initial velocity? So we look at our x and our y direction. Remembering that acceleration only acts in the y direction. Acceleration we assume to be 0 in the x. We assume that gravity is pulling us down with negative 9.81 meters per second squared of acceleration. We assume that as the object is traveling in any fashion, there is no air resistance. Therefore, there's no negative x acceleration. So in the x direction, we only ever have one equation. When we're looking at projectile motion, the x direction only can ever be one specific equation that does not involve acceleration. There's only one equation we've used this year with kinematics that has no acceleration. What equation is that? We have four choices, right? We've got VF equals VI plus AT. We've got x equals VIT plus 1/2 AT squared. We've got VF squared equals VI squared plus 2AX. And we've got V bar equals x over t. Four equations there. Which of them does not have acceleration in it? Yeah, the last one. V bar equals x over t. V bar means constant velocity, and we assume because there's no acceleration in the x direction, this object is moving with the same velocity the whole time in the x. In the y direction, what's happening? First it slows down, it gets to the top, and then what happens? Speeds up negatively. So in the y direction, this object is slowing, stops in the y direction, and then starts to come down, so it speeds up in the negative y. But the whole time, even when it stopped at the top in the y direction, it's still moving horizontally. There's always Vx in these problems. So we know we can write this first. Vix equals Vi cosine theta. This diagram kind of got in the way of the writing here. I'm going to scroll down and write the stuff at the bottom. Okay, Vix equals Vi cos theta. Viy equals Vi sine theta. This needs to be memorized for sure at this point. You need to know this. You need to know Vix and Viy are cosine and sine. It may or may not be. I don't think it is personally. Is it? No? Okay, yeah. I don't think it ever was. Guys, the stuff with the trig components come up with forces. They come up here. They come up later on with... What was the third thing we did that had components? Sine and cosine. There's three things. Projectile motion, forces. There's something else that we did that had sine and cosine involved in it. What was it? Yeah, work. Thank you. FD cosine theta.
Do you leave your reviews for tests up?
All the videos are up for the whole year. Any video we ever recorded for any classes are always up all year. So we know what theta is, right? What's theta in this case? 30 degrees. Cosine of 30. Do you know this by now?
1.
Have you not done this yet in your class in math? Cosine 30, radical 3 over 2, sine 30
We
is
did this like 1/2.
1/2. Very good. So this is really
Wait, why did we get to radical 3 over 2?
guys, I'm just plugging in 30 for theta, and I'm giving you the angle. You did this in math class at this point. That's why I'm saying, did you do this yet?
It's a unit circle.
You definitely did this. It's the unit circle. It's your okay, yeah. So I'm just replacing it in exact value. You could put 0.866 VI or 1/2 VI, either way. Okay, but all I'm doing is just rewriting this equation so we have a number with it now. We don't need that there anymore. So we've got x, we've got VIX. What's the third variable that we're looking for in the x direction? What's the third variable? What is it? Time. Time is our linking variable always. So we still don't know what time is. We don't know what time is over here. What else do we know in the y direction? Is? Good. And it's negative, remember, because we're looking in the negative or downward direction for gravity. So on the left-hand side of the equation, looks like we have a lot of info. But we're missing VI and we're missing t. So again, we're missing how many variables? 2 variables. Over here, we're missing VI and we're missing t. 2 variables. So I'm missing 2 variables twice. But that's not a problem. How come that's not a problem? Good, because there are 2 equations we can use. So on this side, our general equation is always this. Now, V bar is just VIX. It's the same thing. These are identical. Okay, write a little note if you didn't know that. Why are they the same thing? Because there's no acceleration in the x. So I could call VIX V bar, meaning it's a constant. This is a constant velocity, or simply VIX. The same thing works. But plug in at least VI root 3 over 2 here. That goes in there. For x, we can plug in 300. We don't know what time is. So below this little red line is our equation that we're going to utilize here. Okay, again, V bar, average velocity in the x, which is VI cosine 30, equals displacement, which is 300, over time. I don't know either VI or t, so I definitely need another equation. So then I move over to the right-hand side. What equation involves y, VI, a, and t? Which of our other 3 equations involves y, VI, a, and t? Yeah. So y equals, let me just put it actually above this red line first, and then I'll write the rear version below it. We're going to use this one. Y equals VIYT plus 1/2 AT squared. I'm putting little y subscripts there, just so you know. Okay, those are little subscripts. Y is negative 200 equals VIY, which is 1/2 VI, so I've got 2 equations, it looks like here, and I've got 2 unknowns. My first unknown is VI. It appears here, right? And it appears here. T appears here, but T happens to appear here and here. So what should I do? What kind of an approach should I take? I want to solve for VI eventually, right? That's my goal, is to get VI. If I solve, in this case, for VI and replace it here, I get rid of VI and I could solve for time and then go back in and get VI. Or I could flip-flop, ready? This T right here, make sure you're watching what I'm doing. I could flip-flop this T with this whole expression. That'll give me T, but then I get 300 over this whole thing, and that would have to go here, and it would have to go here and be squared. So that's really messy. So I would actually solve for VI, okay, by getting rid of this, plug that in over here.
Why don't you find out what VI is in 302? It's like use 30.
Root 3 over 2 is 0.866, but that doesn't give me an actual value.
Not VI yet.
I don't have VI.
yeah.
The goal is to figure it out. So the reason I would solve for VI is because VI, if you solve for VI over here, wouldn't T be in the denominator? And then when you plug it in here, wouldn't that T cancel with this T right here? So it makes sense to take this approach. So there's more than one way to do these problems, but one of them makes more sense. So I'm going to solve for VI over here, and watch what I'm going to do. I'm just going to multiply by the reciprocal of that fraction. See the radical 3 over 2, multiplied by 2 over radical 3 on both sides. So this is going to become 600 over radical 3 t. Again, how did I get that? I multiplied both sides by 2 over root 3. By 2 over root 3. Those cancel, the 2's and the root 3's cancel. 300 times 2 is 600 over t times root 3. The reason this is very important to do it this way and not the other way, because if you solve for time, you'd have to plug it in 2 spots, and you'd end up with a VI squared in a denominator, which is really just a mess. So take this expression and go ahead and plug it in for VI on the right-hand side. I'm going to write that all down below on the bottom together. Okay, the resulting equation becomes this. Negative 200 equals 1/2 times that whole expression I'm about to plug in. And now instead of plus 1/2 times negative 9.81, I'm just going to write minus 4.9. It's 4.905 really, t squared. So the expression I'm going to plug in is going to be this expression 600, and I'll put it in red so you can see it, over root 3 times time. That's what VI is equal to. Well, if that's what VI is equal to, I can plug it in for VI, and now I can cancel. Time and time cancel each other out. So that gets rid of these variables here, which makes this very, very convenient. All I'm left with is t squared, and it's in the numerator. This is a number, this is a number, take whatever number is here, move it over, divide by this number, square root it to get time. It wouldn't make sense the other way around. Again, if you had solved for time, you'd have to place it here and here. And you'd end up with a VI in the denominator here and a VI squared in this denominator. You'd have to find at least common denominator, multiply everything by VI squared. It'd be really messy. So take the path of least resistance, or the easiest approach. Okay, this would become 300 over root 3. Okay, and then just solve for time. Once you solve for time, look what you can do. Watch where I'm pointing. Plug time back in up here. Okay, again, solve for time, get yourself a number, plug it back in here. It will give you VI.
The bell just rang.